So good morning, everyone, and this is also a joint work with the Technion. Okay, so as we all know, social media become very popular, and hence it's not surprising that also if you look on the customer relationship management, we see this become a very important platform. So what we see conversations between human and agent, service representative, over the social media, Twitter and so on. As we all know, those type of customer support conversation, they bring some problem, but also a lot of emotions. And in this research, we study how we detect emotions from the customer side, and also how we predict what should be the emotional technique of the agent, and I'll explain a little bit what is emotional technique later on. Okay, so yes, it's very popular. Customers are using it, and also from the emotion part of research, we know that those are correlated with the user experience and satisfaction. So they are very important, and we studied two different problems. The first problem is for the customers. So we detect a bunch of emotions. You see confusion, frustration, anger, and so on. And the idea is then, when we're able to detect them, to use them, either to provide some indicator of the quality of service, or actually help the agent to understand what is the emotional state of the customer and do something with it. On the other side, we have another problem coming from the agents. So although they are human, we treat them a little bit different, and we talk about emotional techniques. So they don't show usually frustration, but usually they show some empathy to the customer, apology, gratitude, and cheerfulness. So it's a list of different emotions. And if we be able to predict which type of emotional technique they should use, then we can help them to improve the service. And also, if you think a little bit further, if we want to replace them with maybe a virtual agent, then we can mimic this behavior, so it will be more comprehensive. Okay, so this is an example, as is, from Twitter. So two things to note. First, if you worked with Twitter data, this is very different. You've seen no garbage at all. I didn't change even, I think, a comma. So it's very high quality of data. People need help, so they express themselves very clear and good. And you can see here it's a conversation. On the left side, you see a customer. So the customer initiates the conversation over the chat. On the green, you see this is the agent response. So just if you look on the first sentence, the customer is reporting on some problem, and then it ends with some bummer and some emoticon. From the agent, you see that he responds with "oh." So this is what we call some kind of emotional technique. There is some confirmation or acknowledgement that I understand there is some anger or frustration from the side of the customer. And it appears through all, in this example, through all the conversation. So what we did, we gathered data. We used Twitter, two North American company. One, we call it General, it's General Customer Care, and the other one is more technical customer care. And we gathered around 1,200 dialogues per each of the companies. You can see here the log distribution, and what is very clear is that those conversations over the social media, they tend to last between 4 to 10 turns. Very few are longer than 10 turns, and this is due to this platform mainly. Okay, so collecting the data, then we extracted some features. We extracted actually four families of features, what we call integral, emotional, temporal, and textual. In addition, we also have something that we call attribute. It can be global. So, for example, if there is a dialogue, usually there is one topic because those are kind of short dialogues, then this is global to the whole conversation. versus what we call local. So conversation, it's a list of turns or utterances. So each one we call local. So each step or turn is a local. And also we have some notion of historical. In the historical, the idea is to be able to use previous turns in order to improve the detection. So for example, if the customer was angry 2 turns before, we might want to capture it even in the current turn. So we have some dialogue topic. We had what we call agent essence. Basically, agent essence is some business action that the agent is suggesting usually or asking. We have the emotion of the agent, the customer, some temporal features, and also all the textual like unigram, bigrams, some emotion lexicons, emoticons, and so on. Okay, so as I said, we have 2 different, inherently actually different tasks. The first task is to detect the customer emotion, and the other one is to predict the emotional technique. We treat each one separately as a multi-label classification because, for example, the customer can be also angry and confused. So we want it to be multi-label. And we tried 2 different classification models. One is a regular SVM, and the other one is SVM HMM. The main difference is the way that we treat the features. So in the SVM, all the features that you saw before are provided to the as a feature vector to the model, versus in the HMM, we just give it a sequence of the turns and the features, and then it predicts the label by itself. Also here you see an example of what is history. So if we want to predict the customer emotion at turn I, then if we go to history size of 3, so we have to actually take in features coming from the agent emotion, previous customer emotion, 2 turns before, and the last turn from the agent itself. Okay, so from our data, we sampled around 400 conversations, and we gave it to Mechanical Turk. Each conversation was tagged by 5 Turkers, and each Turker got the complete conversation. We asked them to tag the emotions and from 0 to 5, and you see here the list of emotions and number of instances, also the dialogue and the agent essence, which can be like recognize issue, asking for more information, providing explanation, and more. Okay, so the first result is about what is the optimized history that we want to include while we try to predict or detect the emotion. And you can see here, the top part is for customer, the lower is for the agent. You can see many things. What is actually interesting is that for the customer, it seems that the optimized one is a size of 3. It means that we have to go back in the history, 3 steps, and include all those features while we're trying to predict the current emotion. Whereas for the agent, the optimal window was actually 1, meaning that we only have to take into consideration the previous turn of the customer. Okay, so some more results. On the white there, again, top is customer, bottom is agent. We try to evaluate how each of the feature, the different families improve the quality of the detection. So we start with what we call a baseline. The baseline is basically the textual features. So textual features, this is actually the state of the art. And then we start to add different features, and you can see for both agent and customer that the integral was the dialogue topic, where the turn-up and so on, and emotionals improve or were the most informative, so help us to improve the detection, the quality of the detection. Finally, you can see most details about the F measure for the different tasks. And actually what you see here is that we start with a baseline. You can look on the total First, for the customer, we start with a baseline of 0.44. And then the improvement using SVM HMM was by around 18% to 0.51. And for the agent, you see from 0.271 to 0.417. And probably you are asking, oh, this is still very low. But what you have to consider and to recall is that even when we give the same task for people, the ICC, the agreement level between the target between people is low, and this is a very complex task even for human. And basically we know for different type of emotions it behave a little bit differently, but those seems to be not that bad results at all. Okay, so to conclude, so we found dialogue features to be informative, and we saw that our models both outperform previous models, and basically when we have informative feature, we want to use this SVM HMM. That's it.